Hey, so we are going to be looking at a tool that I probably spend way too much of my time looking at, understanding, reading into, fiddling with, and that is DBT. We are going to be looking at 5 ways to run DBT Core or something very similar in this day and age. Because in the past few years, since DBT came out, there's not only been a bunch of ways to kind of run it and orchestrate it and interact with it, but also some very worthy competitors that have had different levels of traction and can be used for various different use cases, though DBT is still probably leading the market, really. And we're going to do this of the use case of anyone who's currently looking for a transformation tool to set up a new team or new stack, or they're just getting to kind of the limits of DBT Core and wondering, what's next? Like, how can I level up my DBT Core project without spending loads of time rebuilding it in some other platform or even bolting on a whole bunch of extra tools just to give me out of the box what I felt like I should have got with it in the first place, like some observability and actual nice developer experience. So let's dive in. We have Orchestra with DBT Core. Now, Orchestra is not a direct competitor to DBT. It's not going to be, your transformation tool, but this is a way of running DBT Core, perhaps a project you currently have, in as simple a way as possible and getting kind of as many new exciting features out of it as you can possibly get in one sweep. So if we take a quick look at Orchestra's website, we can see that they pitch themselves as the best way to run DBT Core. And scrolling down, they have a whole bunch of kind of proprietary features that they'll give you for your DBT project. So things such as state-aware orchestration, which only runs models when they need to be run based on freshness and SLAs. Some kind of out-of-the-box CI/CD so that you don't have to build whole new workflows just to get slim CI, impact testing, all those kind of niceties that you want before you merge things into your DBT project. And you still have this kind of graphical user interface in case people want to come and build and edit bits of pipelines or manage them with an interface rather than through code. So, being an orchestrator, it obviously comes with a fair few benefits, one of which being there's no infrastructure to kind of set up just to get your DBT project running at production grade. You can click to start, import your project, run it, and get everything kind of out of the box, including observability, alerting, lineage, data quality metrics, all sorts of stuff. You don't have to move away from your current DBT project, so literally nothing to learn. You have DBT, you understand it, you know the project, nothing to change, nothing to migrate. And finally, Orchestra has been shown to run large scale DBT projects as well. So it's not going to shy away from your many thousand model project, like perhaps some of the others may struggle with. On the downside, it still uses DBT Core, so you are at the mercy of whatever happens with that project. Though you could switch to DBT Fusion and run that, but that's kind of up to you still at this point. There is no self-hosted option or open source for Orchestra itself, although their DBT state-aware part has an open source portion. The platform itself does not allow self-hosting, so you'd have to have an Orchestra account, but you can set one up easy enough. It's not transformation specific. So if you did want to add just a single transformation tool to your stack and that's what you're looking for, it might not be for you, but these days that probably isn't even the way to go. It requires a little bit of onboarding because it's potentially new to some of your users, but obviously they get all the familiarity of the tools they know. They just have to connect them to Orchestra and then they get all sorts of other stuff out of the box. And finally, Orchestra is unopinionated on your kind of DBT design pattern. So as much as it's capable of handing you a lot of observability and a lot of scale, it's still down to you to design and manage that in a way that suits your projects. So overall, probably the easiest way to enhance your DBT project and get a lot of kind of new production grade features out of the box, as well as improve it over time using things like agents and other kind of features of the platform. Next up, we have SQLMesh. Now, if you haven't heard of SQLMesh yet, where have you been? But in terms of replacements for DBT Core, it's probably one of the key competitors over the last few years, and it got pretty good traction before being somewhat acquired by Fivetran, where they bought the parent company. But the project itself was donated to Apache, so it's still out there in the open source community for you to use. Taking a quick look at their kind of website, you can see they pitch themselves at kind of more than being just an alternative to DBT. And if we scroll through their core features, there actually is a fair difference in how they approach data transformation to how DBT does. But out of the box, they will allow you to run your DBT projects with SQLMesh as a kind of wrapper around the top. So minimal migration. And some of the other pros that people really liked were the fast execution. So SQLMesh was written in Rust straight out of the box, which gave it a massive performance advantage over DBT Core to begin with. It also supported kind of Python rather than the Ginger syntax that DBT wanted. And that sat a little better with developers out there as it was something they were a bit more used to. And on top of that, some of the more dev-like experiences that SQLMesh made a priority suited people who didn't want to have to set that up for DBT. So things like virtual environments, which is like copies of data for CI or development work, were kind of out of the box supported. And things like backfills, they had much nicer mechanics for than DBT. Along with that, SQL Glot being built into it meant that adding new languages and support for other warehouses was very, very simple. This also came with some nice features such as column level lineage, which at one point was a bit of a hype word. Cons, this came with a steeper learning curve. Not everybody's used to SQL Mesh. They've probably been using DBT, so they're going to have to learn a new framework. Similarly, you still have to set up infrastructure to actually run and manage SQL Mesh. It doesn't have a kind of built-in orchestration or UI or anything like that. There were no kind of packages or open source community bits quite the way there were with DBT. So as much as there was decent support, it didn't come with kind of pre-canned transformations that other people would publish. And finally, if you have a very complex DBT project, it didn't necessarily work out of the box, but this is only for those where you have like lots and lots of packages or crazy macros or extensions or whatever people do with DBT. Overall, SQL Mesh was a really good alternative to DBT, but the paradigm was a little more kind of Terraformy than DBT, I would say, where developers were encouraged to think of more of like a plan, review, apply kind of step than DBT's kind of run and hope for the best, which means it perhaps gears itself a little more towards the engineering heavy teams, but those are also the people who could take the most advantage of it if they're willing to then go through all of the kind of setup and infrastructure and wrapping around it. Next up, we have Dataform. That said, the actual framework is open source. So for those who are curious or want to contribute their own fixes or suggest new things, there is the ability to kind of go to GitHub and start interacting with it. But the core product is obviously kind of based around BigQuery and doing transformations within there, which means for those who are already on GCP and using BigQuery, you kind of get these features out of the box somewhat, and they're kind of there for you to just take advantage of whenever you feel free. And there's no harm in trying them sometimes. So fairly obviously, one of the advantages here is if you're in BigQuery, it's just there for you. And in terms of its actual implementation, it's pretty familiar to DBT in terms of things like the way you use ref and do testing and documentation and Git backed. So those kind of concepts are pretty similar to anyone who's been using DBT up till now. And for the really basic use cases of scheduling, there is a kind of built-in UI to do this, though once it starts getting a little more complex, it's probably not the one to go for. And again, the main real reason to use this is if you're kind of in BigQuery anyway, but it's definitely becoming a more popular tool that people are talking about, so it's worth looking at. When it comes to cons, the main one is obviously going to be it's tied to BigQuery. If you're not in that environment, this probably isn't going to be the most useful tool for you. So if you have multi-warehouses in your company, it's probably worth at least considering something else, though ultimately it's data. You could probably find a way if you've got the time and energy. Dataform is SQL first, but unlike the others, it doesn't have lots of kind of Ginger or Python to allow you to do complex user-defined functions. It does have some JavaScript support, but who's going to write functions in JavaScript when they write SQL every day? Historically, some of its features have been a little lacking in terms of things like partitioning and schema evolution, but that could probably be worked around by the user or has had some recent updates anyway. Another downside is, again, the smaller ecosystem, not just for packages, but also for kind of community, people to ask questions of. It just doesn't quite compare to DBT cores. And that comes at a bit of a downside when it comes to finding talent as well. So overall, it's a low friction, good choice for people who are currently running GCP or want to do most of their transformations within the GCP Cloud Suite. And as long as they're also fairly standard transformations with limited complex logic, you should be able to get away with it. But for those wanting to do complex analytics across a whole host of teams, it may not be the best. And we have Coalesce, not DBT's conference, but the actual competitor tool. Now, because it's actually a kind of UI and platform all in one, Coalesce is potentially more of a competitor to DBT Cloud as a whole than purely DBT Core, but that's probably not going to stop people who are interested in either looking at it. So, what's the kind of uniqueness of Coalesce? Well, if we take a look at Coalesce's site, it's all very pretty, but actually, the main thing about Coalesce is it's not just a kind of CLI tool, it's a complete platform. So if we look at the platform itself in their kind of hosted demo, you can see it has a whole kind of visual builder aspect to it that may not come kind of out of the box with some of the more CLI developer-based transformation tools. But that can be a kind of pro and con in terms of who your main users and developers are going to be. Having this kind of visual aspect to the tool obviously means there is a lower barrier to entry for a lot of non-technical or less technical stakeholders, but it generates real SQL underneath, so it is actually kind of production grade, and you can test and look out the SQL that it runs. You get column level lineage out of the box, there's no extra catalog, and it allows you to do some kind of nice things like define templates or reusable bits of code that people within your organization can kind of self-serve and use to do common transformations, a bit like a DBT model. Also, because you're paying for an entire platform, some of the things like CI/CD and those kind of more developer-oriented flows are built for you. But the downside of this is obviously you're restricted to doing it the way that the platform wants you to do it. And although Coalesce does support things like BigQuery and Databricks, it's primarily been developed around the Snowflake ecosystem, so the support there is a little better, but it does work on the others, and they're kind of trying to get to parity. Some other downsides are this is a kind of completely separate tooling. So if you're going to hire DBT developers, then they're going to have to learn Coalesce, and obviously that limits your pool. At the same time, anyone who doesn't know either still has to learn something, but that goes with all of these. Having a UI is great, but sometimes when you have really, really large projects, it can get a little slow because obviously it's trying to render a massive graph for you, which it just can't do. So you'd be better off running this in a CLI or agentic environment these days. There's no kind of out of the box Python model support, though for most teams, this isn't really going to be an issue. Most transformations are probably still SQL defined, so that's kind of up to you whether that matters or not. And finally, being a platform, there is obviously only custom kind of quoting. So for smaller teams, you kind of have to go through the whole procurement rigmarole before you can even get started, which could be a deterrent. So overall, Coalesce would be highly recommended for kind of Snowflake teams or other teams who have a high proportion of those who are not developer focused but want to build and own data transformations using like a UI or something a bit more intuitive than refs and Ginger. And then we have the Databricks component to this. So for those of you running Databricks, you'll be familiar with probably DLTs. And for those of you not running Databricks, you'll be familiar with struggling to find what DLT is on Google because there are so many things called DLT. Now, thankfully, Databricks has decided to kind of rebrand this a little bit. So if we look at their docs, we can see these are now under the umbrella of Spark Declarative Pipelines, or SDP, which you can find as part of their new like Lakeflow area. So a bit easier to find. Great. But what do? Well, the difference between kind of DBT's way of doing things and DLTs or SDP or whatever you want to call it is that these are a little more declarative. So the idea is you define the transformations and then just hand it off to Databricks to figure out when they need to update and run and how, which all sounds very lovely. But this is obviously different to what people are used to. So first of all, let's look at some of the pros. Pro, if you're on Databricks, it's there for you to use. You may as well give it a go. A bit like Dataform for GCP, worth a shot. See how you like it, see how it suits your team. What more is there to it? Underneath of it, you still get all of that kind of lovely Databricks magic. You get Delta Lake, you get Unity Catalog with it, you get instant links to all of the other bits of your Databricks platform, kind of out of the box, all governed by the same IAM policies, etc., etc. So for anyone in this ecosystem, super easy to get started with. It supports SQL and Python, obviously, because it's Spark under the hood. So that kind of parity with being able to write in a couple of languages is still there. And if you're particularly good at it and write nice code, it can be pretty cost effective compared to running dbt on Databricks, at least in the instance of some projects, because of that kind of built-in nature where it kind of has the context that Databricks has before it does anything, whereas dbt is always going to have to kind of ask, if you look at it that way. So in terms of other cons, what actually is the issue with Delta Live tables? Well, fairly obviously, you need Databricks. If you don't have Databricks or you don't have a Delta Lake set up that you're going to try and figure out how to run this on, this may not be the one for you. But if you're using Databricks for more than just a data warehouse, this could be very useful to you. It has a steep learning curve, I would say, compared to some of the other tools. It's not purely SQL based, and sometimes the beauty of these tools is their simplicity. You can get business users involved, get more context in, whereas I'd say Delta Live tables are a little more engineer focused and have a bit of a dev aspect to it, even with AI. If you're not particularly good at writing them, it's a very easy way to spend a lot of money in Databricks. The serverless workflows can kick off whenever they like and run however long they want. So unless you've really got everything together and your observability built in, it's an easy way to burn some cash. If you're looking for purely SQL-based transformations with not a high throughput and you don't want to have to maintain them with a whole engineering team, then this may not be the way to go. And you're still going to have to bolt on all of this sort of governance. Like, it doesn't come out of the box. You get a very good framework, but it's kind of the same as everything else in Databricks. They give you the tools. You've got to build the boat. And there we go. Those are our 5 dbt core alternatives for anyone who's looking to take their project to the next level, really. I would say there are still many, many other ways of running dbt, maybe running SQLMesh or Delta Live tables or all sorts of other ways of transforming data. You could do it with just Snowflake queries and a bunch of tasks if you really don't enjoy doing much else with your time. So check them out, give them a play around, and I would definitely recommend actually looking at all of the alternatives before just jumping to a one out of nowhere, and see which really works for you and which you feel you get the best value from. So yeah, let me know what you think. Cheers.